Hello again. So in this video, we're looking at congruent triangles. But the first question is, what does congruent mean? Well, this word congruent just means shapes, not just triangles, but shapes that are exactly the same shape and size, even if they're flipped. In other words, shapes that fit onto each other. So we have got six triangles here, and I want to show you the congruent triangles. So if we look at this first one here, we can see that this doesn't look similar. We can see that this doesn't look similar, and this one doesn't look similar, but this one possibly is similar, apart from it's orientated a different way around. So if I rotate that, are these triangles exactly the same shape and size? Do they fit on top of each other? And the answer to that is yes. Those triangles are congruent. Let's look at another pair. Let's start with the big one here. It's clear that those two aren't the same size. This one looks like it could be the same size, but we need to rotate it again, see if it fits. And as you can see, those shapes are the same and their sizes are the same. So they are congruent triangles. And these two here, if we just look at this one and rotate it, if that shape fits within the other one, and it does, these two are also congruent triangles. So just to recap, that word congruent just means shapes, or in our case, triangles, that are exactly the same shape and size. Now we can show that because what we can say here, we know with this first triangle, this one, this pair here, we know that if they fit on top of each other, the angles are all the same. The corresponding angles are the same. So what we can do here is show the angles are the same. So that angle and that angle are the same. This angle and this angle are the same. This angle and this angle are the same. We can also show that the sides correspond. So we know that this side is the same length as this side. So we can show that by showing a dash through both. That represents both those sides are the same. We can say that this side and this side are the same. And finally, this side and this side are the same. This single angle here is the same as this single, the double is the same as this double, and the triple is the same as this triple, and the same with the sides. So that's just our straightforward notation of saying what are the same. Let's mark the other ones up. They're the same. That could be a right angle, but we don't know. They're the same. They are the same. And again, they're the same. Finally, and again, that could be a right angle, but we don't know that. Okay, so there we have a very simple introduction of congruent triangles. So a quick recap. Congruent just means shapes that are the same size and shape. So at the top of the page, I've put the statement that congruent triangles are shapes that are exactly the same shape and size. Remember, they can be flipped. Okay, so there are four ways to prove that two triangles are congruent. The first way is to show that all the three sides are equal to each other. Not all three sides are equal, but equal to each other. So for example, if this side and this side are the same, and this side and this side are the same, and finally this side and this side are the same. If all three sides are the same, we can say that triangle is congruent. That's our first way of proving that. So the first way is we have something called side, side, side. Now we just abbreviate that to S, S, S. All three sides are equal. And a second way is to show that a pair of sides are the same, to show that another pair of sides are the same, and that the angle in between those two sides is the same. So in this case, this angle here and this angle here. Now remember, it's the enclosed angle. So in this case, we're looking for a side, angle, side. Notice my pen didn't come off the paper. So again, side, an angle, and a side. So if you think about that for a second, a side, an angle, and a side, side, the same angle, and the same side. Notice that this angle is enclosed by the two known sides. So for our second way of proving, we can say we have a side, angle, and a side. And what I mean by that is that the pairs match, S, A, S. So two sides and an angle between them are equal. Okay, there's our first two methods. Let's look at two more. So for this next one, we have to show that an angle and a side and an angle are equal. So here we go. So let's say we have this angle and its corresponding angle on the other triangle, which is this angle here. Let's say we have this angle and its corresponding angle, which is that one there. What we need then is a side that is between those two. So this side here and that corresponding side. And that is known as angle, angle, side. So two angles and a corresponding side are equal. And this last one is where we have a right angle and two sides. So assuming this is the right angle here, and that is the corresponding right angle, we would need the same side and the corresponding hypotenuse. So in this one, we are looking at a right angle, hypotenuse, and a side, and that is an RHS. So each triangle has a right angle, a hypotenuse, and one other side. And if you can show that between a pair of triangles, you can show that they are congruent. Looking at this question, let's see what we have. Can we show that these triangles are congruent? Let's see if they fit one of our criteria. So if we look at this side, we have a corresponding side of 3 there. And if we look at this side, we have a corresponding side there of 4. And finally, this side, we have a corresponding side of 5. So in this case, we have side, 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 also known as S, S, S. And because those sides are equal, we also know that this angle here is the same as that angle there. We know that this angle here is the same as that angle there. And finally, this angle here is also the same as this one here. Looking at this next question. So let's look at the situation here. What have we got? So we have got this side here, and that is a corresponding side. We have got this angle here, and that is a corresponding angle. And finally, this side here, and that is a corresponding side. So we've got a side, angle, side. And again, that is known as SAS. What about this one here? Can we show that these triangles are congruent? Well, let's see if they fit one of our criteria. Remember what our criteria are. Our criteria are side, 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 angle, angle, side, and right angle, hypotenuse, and side. Well, if you look closely, we are not given any lengths on this triangle, nor are we given lengths on this triangle. If you look at the criteria, we have got at least 2 lengths here, a length there, at least 2 lengths there, and 3 lengths there. So none of them are just angles. Therefore, they are not congruent. Now, it gets a bit confusing really because you might look at this and say, well, this angle and this angle correspond, as do they, and finally, as do they. Now, if I show you something with these triangles here, they can have the same angles, but they might not be the same size. So if I look at this triangle again, I just enlarge it a fraction, rotate it round, we can see the angles haven't changed, but they are not congruent because the one does not fit over the other. You can see that's actually a longer side and so on and so forth. So no, they are not congruent. And just remember, congruent means exactly the same shape and size. Let's have a look at question 8. Are these congruent? So, and if they are, we need to show they are. But we can see we have got a side of 5 and a corresponding side of 5. We can see that we've got a right angle and a right angle, and we've got a hypotenuse, which is the same as the other hypotenuse. So in this case, we've got a right angle, we've got a hypotenuse, and we've got a side. So these are congruent. So if you can show they fit to one of our 4 criteria, you can therefore say they are congruent. Let's take this a little bit further. So in this last question, this is about proving or showing that triangle ABD, so here we go, ABD is congruent to triangle CBD. There's one thing to really note here, is we have got 2 sides that are identified as being the same. So we're going to write this down one step at a time. So when you're proving something, all you're doing is you're stating facts. Let's start with the obvious fact that side AB is equal in length to side CB. And the way we would say that is, we know side AB is equal to CB. And that is given. And that's because triangle ABC is an isosceles triangle. As I said, that's given. Notice the word there, given. So that's the first thing done. I just highlight we've got that and that already. That's also, if you look at it carefully, the hypotenuse. Okay, the second thing we can say is that side BD is common to both. So this side BD is part of this triangle, and this side BD is also part of this triangle. So that is, it's the same length for both, so it's common to both. And that's just given. Okay, so we've dealt with that side as well. So we've dealt with this side here. Now let's have a look at what else we've got. We've got an angle here. Well, actually, that's a straight line. That's a right angle. I know that angles on a straight line add up to 180. And if that is 90, therefore that angle there must also be 90. We just need to explain that. So we're going to say angle ADB is equal to angle CDB. And as we said, they are both equal to 90 degrees. And that is because angles on a straight line add up to 180 degrees. So again, we're explaining what's happened here. Now, one thing I will point out to you is I've written the word angle. I don't need to write the whole word angle. I can show that in a different way. So if I take out those two words angles, you can show it as an angle like that. Okay, so we've got all the information we need. Now we just need to show that they are congruent. So here we go. We know that side AB is equal to side CB. Remember, that's this side and that side. And that is because they are given, and that is the hypotenuse. We also know that BD is equal to BD, and that's because it's a side, first of all, and that's because they're shared. And finally, we know that angle ADB is equal to angle CDB, which is equal to 90 degrees, which is a right angle. Now we've got everything we need here. So we can say, therefore, triangle ABD is congruent to triangle CBD due to the right angle, hypotenuse, and side criteria. So there you have it, congruent triangles. And as always, if you've got something from this, please like and subscribe. See you in the next video.